the only thing left over that could supply 100% of our energy needs, as base load energy, was ocean thermal energy. And so the thesis was, Bitcoin mining and high density compute provide this incentive that can help Hawaii achieve our 2045 goals.
Welcome back to the Zoom Out podcast. I'm your host, Tim Niemeyer. Today I have the pleasure of talking to Nate Harmon, OceanBit Co-Founder and self-appointed glorified plumber, which I absolutely love. I want to hear how that came around. Nate, thanks for joining me on the podcast.
Aloha, Tim. Pleasure to be here.
Pleasure to have you. What time is it there in Hawaii?
Oh, it's about 11 a.m. It's,
nice.
It's a beautiful day outside. Beautiful Friday. Aloha Friday.
Yeah, man, you're going to have to get out after this and get some sun. I love it. We're in the Midwest here at 4 p.m. and it's blazing hot. And yeah, I've already been out a couple hours and just got softball later tonight. But we got some time. My daughter, by the way, is an amazing softball player. 9U, I'll tell you about it. Same thing with my son, 11U, these guys. But we're here to talk about you, not about me, even though I love to do that. We talked, so OceanBit, man, you are the co-founder of OceanBit, and while I want to get into that first and see how this is a solution, like we were talking offline, you can't really talk about the solution without understanding the problem. And you got a really interesting background that I'd love for my listeners to talk to hear and understand. Can you kind of take us back way before OceanBit? Like, as you're growing up, you're starting to see this problem form that you eventually come to the solution. Can you kind of walk us through that step and take us on a journey?
Sure. How far back do we want to go? Let's start.
Well, you were born
my wife and I...
No, I'm just kidding.
Well, my wife and I moved we met in the Florida Keys and moved out here to Hawaii. I was a scuba instructor and she was a dolphin trainer. So, it was fated to meet. And we met in the Keys and then decided to move out here to Hawaii. That was 13, 14 years ago at this point.
Okay.
And, I was, again, working as a instructor for scuba diving locally, and I saw a lot of the same things that I had been seeing in the Keys, right? Coral bleaching events, destruction of, coral habitats, and general misuse and mismanagement of ocean resources. And so after a couple of years of working and being a graduate of the 2013 bull market, I was able to put myself back through university. I went back to school and got my bachelor's in environmental science and continued on for a master's in chemical oceanography or marine geology and geochemistry. I worked on autonomous sensing platforms, doing analytical chemistry, method development for nutrients, and built like
underwater basket weaving that you would think of in a college course. No.
Right. Yeah. No, this is the basket happened to contain a lot of electronics and did a bunch of chemistry. So it is underwater basket weaving.
Yeah, just a very glorified type, right?
And so during my time at Manoa, so the University of Hawaii, Manoa is the main campus. I had, dove deeper into Bitcoin, right? I built this robot, so I had to learn how to program things, had to learn the engineering side, and I used the opportunity to, learn how Bitcoin worked at its core, right? I started with Mastering Bitcoin by Andreas. It's the best book in the space, right? I always recommend it. It's a textbook, and I'm a big fan of textbooks. And so, through that, I started to understand the mining process more and decided to set up, I was a lab rat, so I had an office
Right.
just kind of sitting there, not really doing anything, and free cooling, free electricity for me, not the university.
Sure.
Decided to set up some some miners there.
Officially, of course.
And then, through this process of just learning how mining works, setting it up, seeing the rewards, I started to put together how, of course I'm an oceanographer, environmental scientist. I started to put together this thesis that Bitcoin mining is the ideal tool for the green industrial revolution, where Bitcoin mining provides this incentive for renewable energy that didn't exist outside of the state. Right, the state
Right.
can provide subsidies for renewable energy, but Bitcoin provided this independent subsidy sort of for renewable energy, and that's because of the difference between fossil fuel or hydrocarbon based energy and renewable energy, where hydrocarbon based energy, you have to continuously acquire hydrocarbons to light on fire to extract energy, right?
Hmm.
Whereas renewable energy is, you're just gathering it where it already is, right? The
Sure.
sun shines, the wind blows, right? You don't have to pay any money for the sun to shine. You don't have to pay money for the wind to blow, and you don't have to pay money for the geo to therm, right? And so, and it's not always producing energy at the time that that energy is needed by the grid. So the marginal cost of that energy, renewable energy, can not only go to zero, but it can go negative, as we've seen in Texas,
Sure.
and a number of other locations, right? And so this, Bitcoin provided a revenue source where there wasn't one. And, it was around 2015, 2016. And Mackay Ocean Engineering was building a small scale OTEC plant on the big island of Hawaii. So, of course, the entire oceanography department is, we're, having lectures, we're doing seminars, we're going to visit, and it started to come together how Bitcoin, outside of just that financial incentive for curtailment, right, that
Sure.
wasted energy for renewables, that there was a more intimate connection between what I call what's called high density computing,
Okay.
which Bitcoin mining, of course, proof of work is just one aspect of, right. Think AI training,
Sure.
supercomputing. There's a
Digital asset
number
compute.
of,
Yeah.
yeah, that's high density compute. You have a bunch of servers that need, in close proximity, a lot of energy going in. It's not your typical cloud compute. It's kind of this whole sector of the computing world, and how there's a novel sort of intimate connection that can be had between high density compute and low temperature thermal engines like OTEC, right? And
OTEC
so then I
being,
started to put it.
can you spell out OTEC?
Sure, sorry, yeah, of course. OTEC stands for Ocean Thermal Energy Conversion, and it's a subset of geothermal energy, except instead of pulling the heat from below the surface of the from the heat generated inside the earth and pulling it up,
Sure.
you use the heat that's trapped in the surface water, right? The sun shines over the ocean all day, you know 12 hours a day, right?
Right.
That heats up the water at the surface, and about a 750 to 1,000 meters below the surface, there's freezing cold water.
Now my
And
6th and
all
7th grade
energy
science is starting to come back. Yeah. Uh,
And all energy generation is just moving heat from one place to another and extracting that, the difference between that. So ocean thermal energy is produced by that difference in temperature between the surface and the deep. And that temperature difference between the surface and the deep happens to be lower than the heat, the waste heat produced by high density compute.
Sure.
And there's a number of other ways that it's really helpful. Of course, as because it's dependent on the sun, there's differences in the surface temperature, throughout the year and even
Okay.
between day and night cycle, right? And so Bitcoin mining, other high density compute applications provide this demand response to differences in generation or differences, between day and night, between summer and winter, right? You can ramp up or ramp down these, ASICs or GPUs, think overclocking, underclocking, to change the amount of power that's being, used at any one time, either freeing it up or using it so that you're generating revenue on 100% of the energy you can produce.
Let me make sure. I actually want to pause for a second and back up because I'm seeing this tragedy of the commons that you're describing from the environmental aspect in specific relation to the ocean, right? We have,
Yeah.
and you also have all of these natural resources or all these benefits of the ocean that you're describing. And then you're also becoming, then that's like one path of your life. And this other path, you have Bitcoin since 2013, man. Jeez. So you already had a pretty intimate understanding of what this is by the time you get to this time in your life where Bitcoin mining provides, not only the number go up aspect and the scarcity aspect, but with this Bitcoin mining and this, and I'm trying to put these two kind of parallels together. So we got the Bitcoin mining, we have the ocean. Your brain just it's just like, when are we talking about when this happened in your life where you started to bring all this together, where the benefits of Bitcoin mining, the benefits of the ocean temperature difference and all that. When
This
are we
was
talking
around
about?
2017, 2018 during my master's program in oceanography. I was, as of course, as anyone does, when you're learning about Bitcoin, you want to talk about it all the
Yes, you do.
time. Um, and so I would talk about it with my, my colleagues, with my professors, um, at the university, right? And inadvertently, sort of spawned the environmental backlash to Bitcoin.
Is that right?
Because the world famous paper Mora et al. That really started and is really the only paper ever cited as Bitcoin being bad for the environment.
Which is riddled
That
with
was,
falsities.
Dr. Camilo Mora is professor at UH. He's
So
actually
you
a
stirred the
very,
pot. You're the
very
one, huh?
good professor. Well, he's an incredible scientist. And it should be noted that the paper was not actually written by him. It was
Yeah.
part of written, and it's not even a paper; it's a note. It was written by an undergraduate class.
Huh.
As part of the class was to, you pick a topic and you spend a semester learning about the publishing process,
I never
and you
did that.
write your first paper, as a class, and then you publish it. I I knew two of the TAs for that class and had talked about Bitcoin with them, and that was they were the ones who suggested Bitcoin and its environmental impact as the topic of the paper, because those were the things I was talking about with Dr. Talladay, who's the second author, and Randy Rollins, who is the third author on that paper.
Huh.
Yeah, I'd been talking about that theory about how it's good, it provides this financial incentive for the renewable energy transition. And well, they suggested, Bitcoin mining as a topic for the class,
Oh my
which
God.
of course had long-ranging implications, and we're still dealing with the fallout of that.
Yeah. So 2017, I need to ask though. So you had that. Did you ever have any, this is just a personal question, did you ever have any conversations with like Brandon Quittem? Because the pioneer species, what you were describing earlier, that was like my base understanding of like what you're talking about. Did you ever talk to him growing up?
Yeah,
Early years?
no, me and Brandon have talked multiple times at a couple conferences. I like him a lot.
Yeah, and that paper really helped me understand like the benefits. So anybody who hasn't read that, don't read the Mora et al. Read Bitcoin as a Pioneer Species.
Yeah,
Okay,
yeah, absolutely.
so here we are in 2017. Past that, when did OceanBit come around?
Yeah, I founded OceanBit in 2022 or
Well,
so.
we still have like 4 or 5 years before we even get to there. I'm just interested.
Yeah, it was a it was just it was a theory during graduate school, but obviously, it took a while to really coalesce as a business opportunity. And so I worked, consulting, software development in the Bitcoin space
Sure.
for a while there. And then I got the opportunity to give a talk, a couple of talks, a series of talks at a number of, Hawaii based conferences. And the topic of the conversation, I revived that original OTech concept, right? Partially because I was looking around the state of Hawaii and couldn't figure out how we were going to make this trend. We have this 2045 renewable energy, 100% renewable energy goal,
Sure.
and nobody was talking about how to actually achieve that in the state of Hawaii. And so the talk was focused on how do we actually make that energy transition here locally. And I go through all the different types of renewable energy, including nuclear. And I'm just like, well, we don't have hydropower here. Okay, we don't have a fallout zone for nuclear if something happens, right? God
Sure.
forbid there's a tsunami
Yeah, right.
when, right, on an island, or an earthquake, which we do experience.
Sure. Volcanoes. So
That
yeah.
there's some catastrophe, we have nowhere to go. We're stuck on an island, right? So nuclear is not an option. The geothermal we have is on a separate island altogether, right? We have each island is its own miniature grid, and it's a really difficult situation to we look at the problems that Texas had because they're just a singular grid, not connected to outside grids. But when you look at Hawaii, there are 5 separate grids that are not connected to each other at much smaller scales. And so I'm checking off, solar. We don't have enough. We don't have enough land for solar.
Well,
We
that
don't
makes
have
sense too.
enough land for wind to fully replace our thermal generation. And the only thing left over that could supply 100% of our energy needs, is base load energy, was ocean thermal energy. And so the thesis was, Bitcoin mining and high density compute provide this incentive that can help Hawaii achieve our 2045 goals.
So to help make sure I have this right, being able to supply enough power for everybody consistently is difficult and pricey. So by
Yeah.
bringing Bitcoin mining in, it offsets that cost. You can have that variable load. You can raise the base load, and I've heard so many podcasts on this, and I'm saying it out loud because you know how it is. If you can explain it, that's the deepest form of understanding. So I'm trying to make sure I understand this. So by
Yeah,
raising,
base load is, essentially what you can't turn off, right?
yeah,
So base load is everything connected to the grid that just doesn't turn off, right? So
sure,
you can, for us, you get down to your base load, consumption or load on the grid, in the middle of the night, and that's 600, 700, 800 megawatts on Oahu. And then throughout the day, when people wake up in
lights
the
on, air
morning,
conditioning, all
they
that.
start. And
Yeah.
then, the peak load for the Oahu grid is between 5 and 9 p.m., right? Everybody gets home from work, they're cooking dinner, they're doing laundry, and that gets up to about 2 gigawatts of power, right? And the problem, of course, between 5 and 9 is that the sun's setting. And so you either need to, one, we don't have enough land for the solar, but you would then need battery, or, you need to have wind and battery, or you need to have, you have to, essentially the grid operator, Hawaiian Electric, states in their renewable portfolio standard that we have no other options outside of thermal generation to meet that peaker load. And so with OTEC and our, OceanBit's demand response IP, we're able to meet that peaker load by simply, having mining or high density compute incorporated directly, vertically integrated with the power generation of an ocean thermal power plant. So we can ramp it up and turn it off. We can ramp up and ramp down as needed.
Hey y'all, are you need a Bitcoin? You looking for a way to safely and securely store your Bitcoin? Check out the Bitcoin Advisors. These Bitcoiners are professionals that will provide you peace of mind so you can sleep soundly at night knowing your Bitcoin is safe. Remember to tell them Zoom Out sent you. So from
Or
there,
at the peak load is at the end of the day, right? In the middle of the day, you don't have as many lights on. You're not running your laundry, right? Everybody's at work.
sure,
At night, between 5 and 9 p.m., you're, at home, you're cooking dinner, you're watching TV, you got the
sure,
AC going, you got, you're doing laundry, you're using a lot of extra power, right? So that's going to be your peaker load. Um, and what our IP demand response ocean thermal energy does is, by coupling that compute directly into the generation, is we can ramp it up and down in response to that demand, right? So we can essentially meet both the base load and the peaker load requirements of a grid. And that's a really novel. It turns an ocean thermal power plant into the two most valuable types of generation.
okay. And again, I'm gonna have to pause because you were frozen for like that last minute. I didn't catch any of that myself, so I kind of lost track. And again, I can cut and edit all this. Sorry about that. Um,
Is
God damn.
my I should have
You're,
my internet should be fine. I'm actually connected to Ethernet
you're
right now.
okay. So yours is fine. Mine is like uploading. So if we just hang out a bit till it gets uploaded, then we could probably roll because Riverside records locally and then syncs up later.
Yeah.
But damn, dude. And I had Brian Harrington. He was on yesterday, and he was in California, and same issue. But I was like crisp and clean with Phil just earlier today, so I don't know what to tell you. Okay, can you tell me what you were just saying? Once we got past, we have base load and we have peak, just to kind of catch me up.
So yeah, that's that coupling of ocean thermal energy with high density compute allows an ocean thermal energy plant to meet both base and peaker demand from the grid. And it changes the dynamic because there's something of course in our background research on ocean thermal energy, there's one aspect of it that has really been not discussed in the literature, which is that, right, the difference in temperature of the surface ocean between summer and winter correlates to a difference in power generation, right? If it's colder at the surface, you're producing less power. If it's warmer at the surface, you're producing more power. So
Huh.
if prior to our IP, if you were to build a ocean thermal energy power plant to connect to a grid, you would have to get a power purchase agreement for that base load component based on the coldest day of the year, right? Say 25 megawatts based on the coldest sea surface temperature of the year. And then
Because
every other day of the year, you're actually producing more power than that base load component.
sure.
So one of our team members, Dr. Luis Vega, who's been working on ocean thermal energy his entire, 40 year long career, he had previously been able to negotiate a intermittent rate for the rest of the year, right? Think like, the rate for solar, the rate for,
Sure.
wind, the variable intermittent rate. Well, with our technology, with our IP, demand response ocean thermal energy, we have a buyer for that excess energy, right? We
Yeah.
have a guaranteed buyer. It's already spoken for. And so now that excess energy can be classified as peaker. And that's how, and we can turn the miners off, we can ramp them down, we can underclock them to free power up on demand. And this is really useful for smaller island grids who really have major power differences, or for offshore blue economy use cases
I love that.
where
Blue economy.
they're where they have major differences in power, like if they're offloading whatever they're mining, or they're pulling up oil and gas, or whether they're doing deep sea mining. They have major differences in power. If the sea surface condition is if the current's ripping, you need more power for to maintain a station. So we can free that power up, or utilize it. We can generate 100% revenue on our on the all the energy we produce. And over the course of the year, that excess energy can account for 15% of the total generation over that annual generation. So
Wow.
it allows us to operate more efficiently than any other ocean thermal plant being developed.
So I can see, like, just from what you were starting to list, like, I mean, going back to like middle school or elementary science, it's like, what is it? 2/3 of the Earth's surface is covered by water, something to that
Yeah,
effect.
forty
So,
percent of it, 40% of the Earth's surface is tropical oceans.
and then so you have that variability in the temperature also. Um, oh, so you're while you're creating, or not creating, but you're solving problems at your level, the what is the word I'm looking for? Geez, the possibilities of this idea to be used, it can be used across, as you said, the blue economy.
Yeah, our initial target market is for coastal diesel and gas generation in Southeast Asia. It's a massive, massive market. There's a great quote. The president of the Seychelles just came out, and in his address to the SIDS doc, which is the Small Island Development State, conference. Think the G7, except for
Okay.
small island development states.
Okay.
He says, our islands are burdened with outdated, inefficient diesel generators. We urgently need to replace 10,000 megawatts of aging baseload diesel fuel electricity generation systems. And so he encapsulated in that quote our business proposition better than we had done previously, right? 10,000, even 10,000 megawatts, right? 10 gigawatts of generation equates to billions of dollars in annual revenue. And a lot of these places, right, because they're so remote, the Seychelles, Papua New Guinea, the Marshall Islands, uh, they're paying right now for diesel generation, they're paying 50, 60 cents per kilowatt hour, right? Here in Hawaii, we have the same problem, 46 cents per kilowatt
Which
hour. I
is
don't know what you're
steep.
paying in the middle of the country.
Yeah, like 8 to 10.
So, yeah, 5, 6
No,
times
it's
as
like 12,
expensive
13,
per
12,
kilowatt
13.
hour.
Yeah, but it's variable.
And
But so the thing that's killing me right now is like you hear in the media and all that, it's like they define Bitcoin mining as solving this lottery problem, wasting a bunch of energy, and to hear like the complete opposite of that, it has to shatter some brains. Like I'm sure even in Hawaii, you have to come across some opposition where that just doesn't make sense to them. Like you're speaking almost, a foreign language to them. Do you come across a lot of that?
well, what we hear a lot is, well, why don't you use it for something productive?
Yeah, exactly.
And then I say, well, what can we do that's productive? Part of the time, with fast ramp up, right, second by second ramp up and ramp down times. Oh well, you can produce hydrogen. Well, the problem with hydrogen is that people have looked at ocean thermal cogeneration of hydrogen, and for 40, 50 years, right? Dr. Vega, again a team member of ours, has written multiple papers about the possibility of hydrogen production. Unfortunately, the economics of hydrogen production don't make sense when you have free energy, much less paying 25 cents per kilowatt hour like we're looking at for our pilot project.
So I'm still kind of just blown away by this idea. So with OceanBit right now, where are you guys? Where are you specifically right now focusing your energy? No pun intended.
Sure. So there's four key milestones that we're executing on at the moment. We just received approval from the state of Hawaii to build our R&D facility. So we're building an R&D facility, or doing a technical demonstration of our demand response technology here in Hawaii on the Big Island. We have engaged the Marine Classification Society, DNV, which is the world's largest marine classification society, to do the technical qualification of our vessel design. So we are building power plants into ships, right? We're hollowing out our plan is to hollow out, X oil tankers
And you got a little
or
video
X
of that
bulk
on your website.
carriers,
Yeah.
and to just build the power plant directly into a vessel, right? These are already classed, are insurable vessels, and we're just going to take all the power plant equipment and stick it in the hull. And then so we're going through the technical qualification of our vessel design with DNV that produces a a de-risked, insurable operation and design specs that we can then just that we can go take to a shipyard and build.
I love.
Then we are operating. We were just recently accepted into the Rice Clean Energy Business Accelerator. This is the Rice University is the real is the foremost university for offshore energy. Right, it's in Houston, which is the capital of offshore energy across the planet. And so we're going through that business accelerator program with them. And the last thing is we are going through the feasibility and economic studies for our pilot plant in Southeast Asia. So it's going to be a 25 megawatt power plant located offshore.
I love this. So, so through this whole thing, not only you're helping the locals, whoever's local, with their power generation or whatever business is needing to lower costs and still maintain high levels of energy, variable energy. But you're also, and the part that we haven't really talked about is you're also securing the Bitcoin network. You're helping to further secure the ledger, and it's synergies like that I absolutely love. It's when at least for me, and I'm sure you're the same way in Bitcoin, I always come back to the phrase good ideas don't require force. And to me, what you're doing is exactly that. You have a great idea and it's just going to continue to grow, and people are going to see the benefits, not just for one group, but literally for everybody. Like, oh, that's
Yeah,
amazing.
no, once we get the getting this pilot plant up and running and in operation is will directly lead to a gold rush in the ocean thermal space across the entire tropics, coastal generation markets, and will de-risk it for decarbonizing offshore operations in the blue economy, aquaculture, decarbonizing offshore oil and gas, decarbonizing deep sea mining. It's a massive, massive market with a total capability of 3.5 terawatts of per year. Right, it's a
So
just absolutely massive amount of energy, and meeting the needs and helping the renewable transition.
So help me out, because obviously this is not my expertise and I'm not in the industry. What are the big agencies that you would like to see? Like, I'm thinking of, what is it, NOAA? I don't know if that's even like,
Noah, yeah.
yeah, NOAA, or what big agencies like need to be able to like not only hear this but like grok it, like understand this.
Well, ocean thermal has been around for a while. The
But
DOE
specifically with Bitcoin mining, yeah.
DOE has funded many OTEC plants in the past. Our we've chosen Southeast Asia to start,
Yeah.
uh, because it has the hottest water, surface water on planet Earth, right?
Okay.
And because our generation relies on that difference in temperature, that means that Southeast Asia has the highest efficiency for ocean thermal generation.
Okay.
So it's the cheapest it can possibly be. And so our focus is for that pilot plant in Southeast Asia. They have a massive need for baseload generation that have no other options. And once we have that operational data, it opens it up to, de-risks the technology for, use here in Hawaii, for use in Guam and Puerto Rico, all across the tropics.
I'm just absolutely blown away. And I wish I would have dusted up on my my science knowledge, because this is outside my realm, but I can see just the insane potential for this technology. So I'm gonna have to go back and start,
There
like,
is no energy transition without ocean thermal energy. That's abundantly clear.
I love that. Well, Nate, I want to thank you for sharing your, not only your story, but your insights and your just huge intellect. Like, I am, like, blown away by how you put all these different things together and how your life kind of came towards this one moment. And this is huge. I hope people are starting to see at home, just the everyday person, how it's not just number go up. Bitcoin may not fix things, but incentivizes a whole hell of a lot. And with your work, it's going to be a bright orange future. So I just want to say thanks, Nate Harmon. Thank you for coming on Zoom Out.
Aloha. Thank you, Tim.
Take care.